This
Do you want,
conference will now be recorded.
Lauren, do you want that I will share from my laptop over here? Let me
Pardon?
do you want that I will share over here from my laptop?
Yeah, what do you have?
Yeah, let me start sharing so you will see
Yes,
it.
we do.
Let me know, can you see?
Yes, we can.
So this is our agenda proposal for the October meeting. First, we would like to discuss about our summit, which will be on the 10th of November. Let's look at over there that what is our schedule and what kind of presentations we will have. And after that one, we will have a DriveNet presentation. Any questions, comments, anybody? Okay. Can you see what I'm sharing?
Yeah, we can see it. If you can go to the schedule tab, I think that might help.
Sure. So, but no, let's start first on this overall. So, actual summit will be from 8th to 10th of November, and actually these engineering workshops will be on the 10th of November. Over here, you can see that there's overall 9 different tracks, and then there are like meetings in the morning and meetings in the afternoon. You can see that these times, what you can see over here, so these are Pacific times. And our telco and edge meetings will be on the track 2 and in the afternoon. So it will be from 1 p.m. until 5 p.m. Pacific time. Over here, you can see that what is actually our schedule. So what are timing and what are the presentations and who will give the presentation. And maybe we could go through this one now. So as said, that we will be in the afternoon and the first meeting will start on the 1 o'clock. So the first 25 minutes, we will have this telco and its project overview. And this will be from Craig, Lauren, Jim, and myself. In a meeting room, there will be all rest of the team except myself. Then from 1:25 to 1 p.m., then we will have a radio network OpenEdge server design presentation from Nokia. And so over here, this is on red still. So I think that is it so that correct? We haven't agreed that who is to actually giving them presentation on this one, right?
I believe that is correct.
Yep. Then if it continues, so we have like a 10 minutes break, and then we will continue from 2 to 2:25. We will have a presentation about a framework for upgrading white box firmware in a distributed disaggregated chassis implementation from a service provider perspective. This is coming from AJT, and presenter is Prasanna Ramachandran. Next one is from 2:25 to 2:50. This is a Nokia presentation about the next generation OpenEdge server design, and presentation is done by Craig. Then we have again this 10 minutes break, and then we will continue from 3 to 3:15. We will have a presentation about disaggregated converged access switch for a flexible front haul network. This is coming from Ufispace. Next one is from 3:15 to 3:30. This is OpenEdge server use cases in a private 5G network. This is coming from Mick and the presenter is Alex Cho. So actually the company name is Mitak. Then we have a 20 minutes presentation from 3:30 to 3:50.
On MyTac, just for a second, is there anyone on the call for MyTac here? Okay. We've been trying to get a hold of Alex Cho and don't know if he's attending. And we did not receive a presentation from him, as you can see. So not sure what's going on there.
You mean that there's a risk that this is not going to happen then in the meeting?
Not sure. we're down to the wire here. So we're reaching out to him, but if anyone else knows him, please reach out to him and tell him that we're in danger of canceling his session, basically.
Yeah, but not yet. So I think that as long that MeTag will contact to us, so I think we can handle that one. Yep. Okay. Then next one is from 3:30 to 3:50. Reference clocks in 5G and time-sensitive applications. This presentation is from Rakon, and the presenter is Xiaochun Liu. Then we have again 10 minutes break, and the last we will end our Telco and Edge annual meeting with the panel discussion. So this will last 50 minutes, and the title is Challenges Facing 5G Cloud RAN Providers and Open Source Solutions. And over here, Jim is leading the panel discussion, and Umar Chowdhury from AWS will be also in the meeting room. So then, Jim, you are listing also here the Kaustub Joshi from AT&T and Sid Zenemulu from this. How you are going to handle them?
So what I'm asking is each participant, each panelist to submit 1 to 2 slides that show either examples of what they've done in this space or their general approaches. And then I did get a tentative acceptance from Rakuten as well. So I'm trying to add a 4th panelist. But so most of the people are going through their media teams to get clearance on the slides that they're submitting. I asked for all of those to be provided to me by the end of this week, so by tomorrow. And then I should get final confirmation on Rakuten by tomorrow as well.
Okay, thank you, Jim. So then after that one, then we can add it also like a Rakuten if it's confirmed that they will participate.
Yes, it looks promising, and I'll have that confirmed by tomorrow.
Okay, sounds good. Thank you. Okay, so this was about like a OCP summit and schedule. You know that there are like a few like red items, meaning that either like a presentation is missing or presenter is not confirmed, but otherwise I think it looks pretty good. Any questions, comments? Okay, and as agreed that our next item is this DriveNet presentation, so could you take this ball now and start sharing your presentation, please?
Yeah, who's presenting?
Yeah,
I will present. I will present Evgeny Sendov. So if you can grant me the presentation, right?
Yep. You should see a pop-up come up.
Yeah.
Okay.
I see it. Can you see the screen?
Yes, we can. That's awesome.
No. Great. So guys, first of all, nice to meet you all and be here. So what we want to present is our specification proposal for the firmware upgrade in a disaggregated distributed cluster. So this is a joint proposal coming from DriveNets, UFI-Space, EduCore Delta, and AT&T. DriveNets is it's a NOS vendor for distributed disaggregated clusters, and UFI-Space, EduCore, and Delta are ODM vendors that I will explain in a moment. We all probably know developing ODM devices for the DDC clusters. And AT&T is, I think, the first ISP operator which is running DDC clusters in their network. So the goal of this proposal is to reduce the firmware upgrade complexity in DDC clusters and basically disaggregate distributed mode. The capability to upgrade firmware independently from the NOS version. We would like to create a clear separation between hardware and software in order to simplify the root cause analysis process. And we would like to define a standard NOS and ODM agnostic interfaces for the firmware upgrade process as well. And of course, last but not last, we are seeking optimization of firmware upgrade times in distributed clusters. So if you have any questions, by the way, feel free to stop me and ask any moment. So first, I will really shortly introduce what is distributed disaggregated cluster. So Dragons, as I said, we are developing a network operation system for DDC clusters. We call it DNOS, Dragons NOS. So DDC distributed disaggregated cluster includes several building blocks. First one, we call it network cloud controller, which is x86 machine running the management plan and control plan of the cluster applications. And the second, called NCF, stands for Network Cloud Fabric, which is basically fabric machine that create a fabric data plane. The third one is called NCP, Network Cloud Packet Forwarder. This machine can be equivalent to line cards in traditional chassis-based systems. It hosts network interfaces and fabric interfaces to the NCF if we want to interconnect multiple NCPs to increase the fan-out of the cluster beyond single NCP. And we have the NCM, which is Network Cloud Management Switch, which interconnect all the NCC, NCF, and NCP devices in the cluster into single system. So on top of this, we are running our network operation system, which is running distributively on all the devices. And the NOS is running different applications. So today we are running full-blown IP MPLS router for a core, for edge, and for access applications in network. So you can see here that today we have in production almost 200 terabit per second cluster, which includes 48 NCPs, 13 NCFs, 4 NCMs, and at least 2 NCC devices. So basically, it's a large disaggregated distributed system, which includes a lot of devices interconnected together and acting as a single virtual system. Any questions so far?
I have a question.
Yeah.
So with this distributed, disaggregated architecture, you consume more or less energy compared to the modular architecture, where the chassis, we use modular chassis, which has the line cards and the control cards and management and everything. Which one consume less energy?
So it really depends on applications and how you interconnect it. We have a comparison in terms of power consumption, but it's out of scope of current presentation, but we can discuss it offline if you want.
Okay, thank you.
Sure. So in context of the firmware upgrade, how DDC systems are upgrading the firmware of the cluster. So first of all, the whole process should be managed by the NOS controller because the upgrade order is important. So we have NCMs that interconnect all the devices together. So we cannot upgrade firmware on the NCM and in parallel upgrade firmware on other devices because this way we will break the cluster integrity. And we have the NCCs which are running the NOS controller function. So they should be upgraded first. So the order is metal. And we, as we saw previously, we have multiple type of devices which compound the cluster, NCP, NCF, NCMs, and each one, I'm sorry, someone introduced a lot of noise. Thank you. And we have a multiple ODM vendors in the same cluster. So today we are running clusters with at least at least 3 vendors on the same system, right? So we have UFSpace, HCore, DNI, we have others as well. And as I previously said, we want to manage firmware image versions in a separate way from the NOS versions, which means that it might be that user would like to upgrade firmware on one of the cluster devices without upgrading the NOS. So when you would like to upgrade the firmware, in 2 cases. First, when we're doing upgrade of the NOS. So as part of the new NOS version, we might upgrade the firmware on different cluster devices. Second is when we're adding new device to the current cluster. As part of this process, we might have to align a firmware on the added node to the firmware which is required by the NOS. And as I said previously, it might be that you would like to upgrade the firmware on one of the devices in the cluster without touching the NOS at all, because I know the ODM vendor want to release a new fix to some revealed problem. So that's basically the problem with which we encountered with when we develop our cluster and manage the firmware upgrade process. So what is the method that we adopted for upgrading the firmware in the cluster? So first, we are using only firmware installers as a standard tool for firmware upgrading on all the devices in the cluster. Second, we defined a metadata format which describes for each firmware image in each device in the cluster, describes the image and what is the compatibility with the platforms. I will elaborate later. And we decouple the dependency between the firmware images and the node images, which means that we can upgrade firmware on every node in the cluster without upgrading the node itself. So how we are doing this? So first, as I said, we decouple the firmware package from the NOS packages. So the ODM releases a single package turbo for all firmware images in the cluster, and it includes a couple of files within it. So we have a metadata that, as I said, it describes the package in terms of which platforms, revisions, hardware builds are supported, which components that are supported by this package. It might be that on specific device, on specific NCP or NCF, only BIOS or only BMC will be upgraded by this specific image. And the firmware, what are the firmware versions? What are the versions that this package brings? Second element is the only firmware installer script. So this is a script which running the firmware installation itself. It is written by the ODM, and each ODM is responsible to create its own sequence of upgrading, because each device has different set of components. Some have Ethernet controllers, some have BIOS, some have not. And within the physical device, there is the order of firmware component upgrades is also important. So the script describing the order of firmware component upgrades within a single device. And the last are the binary files, which are basically the firmware images for the upgrade. So the second stage is when the user is downloading the firmware package to the NOS controller. As part of this stage, NOS reads the turbo, basically reads the metadata, and it validates that firmware versions within this package are matching the devices which compound the DDC cluster. And if there is a mismatch, NOS will not start the firmware upgrade of the cluster, because there might be some devices which are missing the firmware images. The third stage and the last stage is when the NOS controller triggers the firmware upgrade on all the devices. So that is done, as I said previously, in specific order. So we first upgrade the controllers, then we move to the NCMs, and then we upgrade NCP and NCFs. So as part of this process, ONI on each device in the cluster boots up, running the firmware upgrade scripts and sending notifications to the controller. So why this notification is important? Because, as I said, we have a huge cluster with 60 or so devices. Each device is upgraded in parallel, and this can take a while. So firmware upgrade of a single device can take approximately 40 minutes. And we want to provide a real-time progress information for the customer. So the customer will be able to see and at real time at any moment which device is upgraded and which component within the device is being upgraded. So the notification format is also defined as part of our proposal. So I will briefly go through the metadata and notification format to get you some perspective how it looks like. So the metadata file, basically a JSON file, is written in JSON format. It provides information about the package, which firmware package versions are included in the file, list of supported platforms and hardware revisions and builds, a list of supported firmware components per each device, target firmware version per each component, and upgrade time estimation per each firmware component. So user before user triggers the firmware upgrade on a cluster, our NOS controller can estimate how much it will take to upgrade a specific device in the cluster and overall cluster. So here we can see an example of firmware package metadata. I will not go through all the parameters here. This can be seen in our OCP proposal, OCP specification proposal. The installer script, as I said, is written by the ODM vendor. This script is running firmware upgrade tools and sending notifications about the progress to the controller. Here we can see an example of notifications. So today notifications are sent by the ONI firmware upgrade script using HTTP messages. So for each component, for each device, we are sending the serial number of the device, the name of the component that is being updated currently. It can be like CPLD, BIOS, Ethernet controller or something. The status of the upgrade, whether it started, done, failed, and maybe some description, which is a free text added by the ODM vendor. So that's basically all I wanted to present. And so we have a OCP specification suggestion, which is written in a standard file, and we are planning to apply it later on.
Yep.
Any
Thank you very much
questions?
for the presentation.
My pleasure.
That method looks.
Guys, any other questions, comments?
The method that you're proposing looks just like the method that was standardized for RMCP HPI maybe 5 years ago.
For the DDC systems?
Yes. Well, it doesn't matter whether it's distributed, but your whole method for metadata and packing multiple firmware images into a single file is exactly what RMCP does.
Okay, could you please send me the reference to the standards?
I would imagine you could Google it and find it easy enough. It's been around for many years.
Okay, I will check. Any other questions, guys, on the matter?
So this is run out of ONI and controlled by the management switches, or?
Yeah, so it's as I said, the cluster, in the cluster we have a machine called NCC. Let's go back to the machine called NCCs. These are x86 machines which are running our control and management plan in the cluster, and they are managing the whole distributed system, and as part of that they're also running the firmware update process.
Got it. Thank you.
Any other questions? Okay, thank you very much. Is there anything else that you want to discuss in this meeting still?
Well, we would like to proceed and to suggest it as a standard for firmware upgrade in DDC systems. So we will check what was said here regarding the existing standard on the distributed systems. So what Michael said, and we will see how we proceed.
But the controller will be in the cloud.
Sorry?
The controller exists in the cloud.
Well, it really depends. It really depends on the deployment. The controller can be a centralized machine which is managing set of devices locally. It can run in the cloud as well. It really depends on the application. So if you are talking about IP MPLS routers, the controller is running domestic locally to the NCPs and NCF, locally to the data plane.
And the fabric can be separate in a separate chassis or separate device, right?
That's correct. So we have multiple fabric devices. Today we compound up to 13 devices.
But this will increase latency for packet switching.
So today we are using cell switching technology. When we are based on the Broadcom DNX product family, where the whole fabric is synchronized in terms of time. So so basically the delay is limited. Of course, we have a distance limitation. So the distance limitation is coming from the DNX technology itself. So the maximum distance between two devices in the cluster is limited, I think, by 200 meters today.
And which Broadcom chipsets you are using?
Today we are working with Jericho 2, Jericho 2C+.
The latest ones.
Mm-hmm.
Okay, thank you very much.
Thank you.
Okay, if there isn't any other items, I think that we can close the meeting today then. Thank you very much.
Thank you very much, everyone.
So.
Thank you, guys.
All right.
Thank you.
Thank
Take
you.
care,
Bye-bye.
everyone. Thank you. Bye-bye.